Welcome back, engineers. We are discussing architectural styles, and in this video let's look at the last and final one, which is microservices architecture style. So this architectural style actually is quite popular and people love to throw the word microservice in almost all architectures, and it is probably the most popular and also probably the most overrated architectural style. So in this video, let's try to understand what this style is all about, why people love it so much, what is the problem it is solving. And before we do that, let's have a quick story. I hope you're ready. Let's get started. So let's say we have a so-so government, right? Not so great, so-so government. And let's say the government is having ministry of everything. There's just one ministry for everything that the government is supposed to do. So the people have different needs, right? So some people need water, some people need electricity, some people need passport services, some people need roads, healthcare, food, whatever. So there can be so many such different needs, and if only one ministry is handling everything, you can imagine the chaos that it brings to the table, right? So nobody knows who is responsible for what. Everybody is trying to access the same building, let's say if it's a government building, and people are just frustrated because everything is delayed and there is a lot of chaos, right? So this is an example of a monolith system where everything is going on together, right? And if for every small change, the whole ministry needs to be updated. Okay, so that's a lot of coupling, lot of responsibility within itself, and also single point of failure. If the ministry goes down, the government is helpless, right? So that is not something we need. So what is the other extreme of this? So the other extreme of this is to split everything. So let's say we have an awesome government that just splits everything. So we have a ministry for transport, we have a ministry for health, we have a ministry for water, some electricity board, some ministry for external affairs to give out passports and stuff. So there can be many such ministries and sub-ministries. There can be boards, water board, electricity board, and so on. So this type of government is a decoupled government. Everybody is responsible for their own stuff. So if there is any inquiry for transport, people can go here. Ministry of Health, people can approach here for health related questions, and Ministry of External Affairs for passport related stuff, and so on, right? So this type of a system has a great decoupling and everybody is responsible for their own stuff. But if you imagine, there will be some stuff that requires common coordination. Let's say all of these boards are reliant on Aadhaar for let's say validation of any citizen. Let's say all of these services need Aadhaar as a validation. So this Aadhaar will be part of another service. Let's say there is some other department of Aadhaar that is taking care of issuing the Aadhaar and maintaining the records of Aadhaar, right? So how do all these systems access it? So they all can make a request to the Aadhaar department like this, and then they can get information, and then they can validate that information and make use of this, right? So there are some services that are reliant by all the other services, and there are some services or the ministries in this case that are not reliant on anybody, right? So this type of a system is called a microservices system, where there is a lot of decoupling between services, right? So how did we break this down into so many layers? We broke them down based on some kind of a service that we are offering, some kind of a workflow that is being offered. For example, all transport related workflows will be taken care by this one. All water services will be taken care by this one, and so on, right? So this is a domain driven breakdown. All services are driven through some kind of a workflow, some kind of a domain, some kind of a service that it is trying to address, right? So this type of a breakup is called as a microservice implementation. Now let's see how the architecture actually looks like. So you must have seen this structure before. There's a client that is trying to access a server, right? So it's a simple client server model, but this time the server is broken down into multiple servers, right? So this server will take care of one service, the yellow service, let's say. This server will take care of pink service, this will take care of blue service, and this will take care of green service, let's say, right? So all of them need to be communicated by the clients, right? And somebody needs to know that there are so many services, and there should be some checks about which service is up, which service is down, and so on. So all that stuff can be taken care in the API layer, right? It can also act as a gateway anyway, right? So client is making a request to the API layer, the request is routed to the respective service, and the response is returned back to the client, and everybody is happy, right? So this is a typical microservice architecture. And if you think about it, everything that the server needs to address the service or the workflow that it is responsible for, everything that is needed by this service will be available inside this. So all the modules, all the classes, subclasses, packages, dependencies, database connection, data, everything that is required for the service to operate, the entire life cycle of it will be available inside this box, right? So it should not be dependent on any external factor in order to fulfill its service or responsibility. Okay, similarly the rest of the services are responsible for their own behavior. Okay, and there might be a case that one service needs information from the database of another service. So in that case, this service cannot directly talk to the database inside. This would be wrong because that would create a coupling, but instead they will talk to each other at a service layer. So this will make a request and this will respond. So it can be either through some REST APIs, or it can be through some message queues, synchronous or asynchronous depending on the requirement, but they can communicate with each other over the network now because they are decoupled servers. They are scaling up on their own, right? So this is how the microservice architecture looks like. Every service will have everything that it needs inside the box. Okay, let's try to understand some of the features of this. So first feature is it is having a distributed nature because everybody is split up now. So if everybody were in the same box, we would use method calls, but because they are distributed, now we have to make use of network calls to communicate, right? And this architecture prefers duplication over coupling, right? What does it mean? It means that the fundamental philosophy of a microservice architecture is to be very decoupled in nature, right? So if this service requires something from here quite frequently, then it's possible that these two services share some duplicated data. It's possible that they share some duplicated data inside the database. Maybe we'll add some additional columns to avoid some calls. Maybe we will add some additional metadata to avoid some calls. Maybe we'll add some additional packages or dependencies inside here and in both the services in order to avoid that coupling between the two services, right? So this architecture prefers duplication over coupling. Now let's talk about bounded context. So the bounded context as a theory, it means that if you have a big lump of mud, okay, let's say you have a big mold of mud in your hand, on what basis do you break it down to create new shapes? Where do you create those boundaries? So in the case of our government example, we had the boundary at a ministry level where we have all these different public services, right? Transport, health, external affairs, and so on. So depending on the public service that we are offering, we were able to break it down. So in a typical software architecture, what is that thing that will help us break it down? So the thing that will help us break it down is a domain purpose, right? So every system is different, but every system can be broken down into different workflows. Maybe there's an approval workflow, maybe there's a notification workflow, maybe there is a email sending workflow, maybe there is some kind of a order shipping workflow, maybe there is some kind of a logistics workflow. So there can be different workflows within the system, and each workflow is addressing some kind of a customer service, right? So depending on these domains, we can actually break it down, right? And we need to try to avoid transactions as much as possible when using microservices. So if there is a case that one service's update to the database should be in sync with another service update to its own database, then we are creating a tight coupling again, and that is not the philosophy behind microservice. So all transactions that need to happen inside this are fine, but if it is spanning across services, then we are opening up the coupling scenarios again. Maybe we need a mediator, maybe we need an orchestrator, and so on. So those are different patterns to address the transaction behavior, but as a fundamental philosophy, we should try to avoid transactions within a microservice, right? And the next one is to create isolation between services, right? Which is something we have seen just now. And the next point is data isolation as a feature, right? So like I said, everything that a service needs should be available within the same box, including the database as well, right? So one database data may be duplicated into some other database, but it shouldn't be the case that one database is accessed by another service directly like this. This is not allowed, right? So we need to have data isolation within the microservice, okay? Now let's talk about the common stuff. Let's say as an architect, I want to build some common stuff across all microservices. Let's say I want to have logging as a feature. Every request that goes to the microservice should be logged somewhere, right? So how do we ensure this stuff? So for this one, we can make use of something called as a sidecar pattern. So every service will be attached to a sidecar like this. There's a sidecar here, there's a sidecar here, there's a sidecar here. So all the common stuff can go here. Maybe it could be logging, maybe it could be monitoring of health and so on, right? So all these stuff can be happening through a sidecar pattern, and this is a pretty common pattern, and this ensures that if there is any update in the common sidecar, then all of the services will receive it and so on, and that way we can keep all services independently but still achieve common functionality using the sidecar pattern, right? So if you want to know more about sidecar pattern, definitely let me know in the comment below. I'll try to provide some more information on top of that. Okay, next up is communication. So we have already seen this before when we discussed how the services communicate. It can either be through some REST APIs or some message queues, depending on the implementation. So they have to communicate over the network now anyway, right? So make your pick depending on the requirement. Should be synchronous or asynchronous. You can make a pick of your protocol, but you have to remember what the other side is expecting as well. For example, if service A is exposing APIs, REST APIs, you can only communicate with it through those REST APIs, right? You cannot say, hey service, I need to make a GraphQL call to you, please give it. It doesn't work like that. Those service contracts are defined up ahead, and the calling service needs to be aware of the protocol that is being used by the service that it is trying to call, right? So those level of communication and protocols must be established up ahead, right? And finally, orchestration. So this is a pattern that is slightly deviating from the concept of coupling. So what we'll do is we'll have a mediator will receive a request. It will go to service 1, service 2, service 3 and so on. If service 1 is passed, then it goes through service 2. If service 2 fails, then it calls service 1 again, asking it to roll back, and then everybody is kept in a consistent state, right? So this is something that should be avoided in the microservices, but if you need to, you can make use of orchestration pattern as well, similar to what we have seen in event-driven architecture as well. So there is a mediator topology, right? You can make use of such an implementation as well. Now this one will be between services, okay? So these are the features of this architecture style. Now let's look at the trade-offs. So with this architecture style, the top 3 pros that we get, or the benefits that we get, are scalability, elasticity, and modularity. So you can already guess why these are the main takeaways. Scalability, because every service is decoupled from the others. So every service can scale on its own. It can have its own tech stack. It can have its own data layer. It can scale on its own. Elasticity, because if there are bursts of traffic coming to one particular service, only that service can be scaled up, and the remaining stuff can be left undisturbed, right? And modularity, this is again a great advantage because we are able to break down our domain into multiple subdomains, and each subdomain can be deployed on its own, right? But not everything is rosy. It comes with a lot of cost because now we have to deploy each individual service differently, and everything comes with a cost. And we have lost simplicity because the coordination, if required, is lost, and it is up to the layer up ahead to take care of calling individual services and then collating information and give it back to the user. Sometimes this complexity is at an API layer, sometimes it's at a gateway layer, sometimes it is at a client level as well, right? So that simplicity is lost. And then there's also a performance impact because we are making calls over the network now instead of making local method calls. And because of this, there is added latency, and every service can have its own sweet time to address any request, and it all adds to performance cost as well. So these are the main trade-offs for this architecture style, guys. If you have any doubts, definitely let me know. In the next video, we'll see how to choose between an architecture style. What is the thought process behind choosing an architecture style? So please stay tuned for that. Please leave a like if you found this video helpful. Please subscribe if you haven't done already. I will see you in the next one. Cheers.